Moving on from our last example, we're going to do another probability question that involves repeating a simple experiment. And here I want to show you a little trick that helps you sort of find a probability that it at first looks like a lot of work, but we can kind of do this sneak attack technique to get the answer really quickly. So again, we're going to roll a fair die 5 times, and we want to know the probability of getting at least 1 4. So let's talk about what that means. At least 1 4. Well, that means getting a 4. So at least 1 4. That means we can get 1 4 or 2 4s or 3 4s, etc., all the way up to 5 4s, right? That's what that means. So if we want those probabilities, one way we could think of it is, well, we just need to figure out the probability of getting 1 4. So let's just say the probability of getting 1 4, we're going to write probability of 1 4 plus the probability of getting 2 4s plus the probability of getting 3 4s plus the probability of getting 4 4s plus the probability of getting 5 4s right? So we would have to figure out all those and then add them up. Now here's the thing, we're not going to do that because first of all that would be a lot of work. I don't know if you refer to the last video, it took us kind of a long time, although part of it was just me talking, but it took us a long time just to figure out that, right? That was the problem last time. So imagine having to do that for all of these. I mean, it would be just too much. But there's a better way to, there's a quicker way to figure it out, and that is to make use of the fact that the only probability that's missing here is the one I'm going to put here in red, which is the probability of 0 4s. Let's sneak that in the front there. The probability of 0 4s. Now, if I add up all these, what I know must happen is that it has to equal 1, because this is everything that can possibly happen, right? Either you get, you roll the die 5 times, you either get 0 4s, 1 4, 2 4s, 3 4s, 4 4s, or 5 4s. So if you add up those probabilities, you get 1. Now, since we want only what's here in blue, what we can do is just do a little subtraction of that probability of 0 4s, and you'll see that what we have is exactly what we want. We want to compute all the probabilities here in blue, and to do it we can just write it as equal to 1 minus the probability of 0 4s. But 1 minus the probability of 0 4s is much easier to deal with, because we just have to compute the probability of 0 4s and subtract it from 1. And not only that, the probability of 0 4s is not so bad, because here, let's do our setup of our 5 rolls. 1, 2, 3, 4, 5. Getting 0 4s means we get a non-4 on the first roll, a non-4, a non-4, a non-4, a non-4, and each of those have 5/6 probability. Which means this probability is 5/6 to the 5th. And the nice thing is that I don't have to consider all the possible ways, like in the last video, that this can happen, because the only way this can happen is this one way that I'm looking at, right? The only way to get all non-4s is just one way. All of them are non-4s. So that means that our answer is 1 minus 5/6 to the 5th, which when you put in your calculator, you get 0.598. So keep that in mind, and look out for the word "at least" here. At least 1/4. That usually means there's a nice sort of backdoor way to get that answer, as we did here.